So to answer that first question, who is RFI? We're going to make a really bold statement to start with, and that is we're Australia's leading antenna manufacturer. And I think we all use words freely like that. Hopefully by the time we get to the end of this presentation, we will have demonstrated to you there is actually a little bit of credibility in what we say there. So a few things that we do. We're experts in wireless technology. So we don't just make UHF CB radio antennas. We don't just make two-way radio antennas. We make antennas for anything that's wireless. Wi-Fi, cellular technology. We even make antennas for remote monitoring systems. RFI's been around since 1979. It's a family-owned company. It still is a family-owned company. And it still has the same family values it had when I joined them 15 years ago. Today we enjoy exporting to more than 50 countries around the world, which I think is a great good news Aussie story, particularly in these tough economic times. We have over 200 employees, the vast majority of which are based in Australia. We turn over in excess of $100 million a year. Our head office is based in Sydney, New South Wales, Seven Hills. We have a manufacturing plant right here in Bayswater in Victoria, where we do all our antenna R&D and manufacturing. We've got an R&D and electronics manufacturing facility in Adelaide, and we even have branch offices in Brisbane and Perth. So we've got a really Australia-wide presence. So some of you, I'm sure, have heard of the RFI brand. Others may not have. One of the things we recognise at RFI is we're probably not as well known as some of the other brands in the marketplace for UHF CB radio product. One of the main reasons for that is we don't actually manufacture a UHF CB radio. So we're not an Icon, we're not a G&E, we're not a Unity. What we are is a specialist antenna designer and manufacturer, and that's our area of expertise. Where we are better known is, the reason for our fire trucks and police cars up on the screen here now, is we're better known for emergency services and professional two-way radio communications technologies. And just as an example of the sorts of RFI products that you will see on emergency service vehicles throughout Australia will be multiple products, such as cellular antennas. We might have multiple RFI products on this emergency service vehicle: cellular, UHF CB, and the police radio network antenna. And similarly on, say, a fire truck, we might have the fire service two-way radio network and a cellular product, perhaps to operate broadband internet or something in the vehicle. We also supply antennas for things like taxi services. And we do that, I guess, for all sorts of professional communication systems. And that's where our expertise lies. What we do is we apply those same principles to what we do in UHF CB radio. If it has to be mission critical for these guys, it's got to be mission critical for our UHF CB radio product. So on to the next question, which is what is UHF CB? For those who might be a little bit new to this, UHF CB operates on 477 megahertz, and that's as compared to the very early CB technologies back in the 70s and 80s. Unfortunately, you've probably noticed I've got a couple of grey hairs. I remember back then. 27 MHz CB radios, much lower frequency, somewhat prone to interference, and because it used AM for transmission, the audio quality was quite poor, so it's a little bit harder to understand what people were saying. UHF CB uses FM, frequency modulation, which basically gives you better voice clarity. The signal on UHF tends to travel in a straight line, and I'm sure many of you already have UHF CBs would be aware of that. As soon as you get a hill in the way, the coverage really drops off, or if you've got a forest in the way, equally. Obstacles in the way, UHF CB usually has some problems. You can get around that by use of things called repeater stations. And what a repeater station does is it's up on top of a hill or a mountain nearby. It receives the weak signal from your vehicle, amplifies it, radiates it off the big antennas on the top of the hill and down the hill, and it gives you much better coverage because the site up on the top of the hill can see much better into the surrounding terrain. It sees over the top of all of those obstacles. Just keep in mind that there isn't a UHF CB repeater in every area. So you might want to think about perhaps having a look online and downloading yourself a list of where all the UHF CB repeaters are, so you know where you can and can't access them. What we're really here to talk about tonight obviously is antennas. So we talk about what is the right UHF communication system? And by that I mean the combination of antenna and radio. I imagine this would be obvious to most, but the radio is important, obviously. If the radio doesn't work, it doesn't matter how good the RFI antenna is. Your system isn't going to work. But equally, if your antenna's poor, you can have the best radio in the world, and it just isn't going to work. So hopefully what we'll do is we'll dispel some of the smoke and mirrors that we see in antenna terminology and help you guys understand what that right mix is to suit your applications. So basically what we like to say about the antenna is it's effectively the ears of your radio. So the radio can be great, but unless it has some means of sending that signal out and receiving that signal back in, it's no use to you. The antenna must be in tune with the frequency of operation. It doesn't have to be in tune specifically with your radio, but it has to be in tune with that 477 megahertz UHF CB frequency. And to do that, we've got some great engineers who work tooth and nail to design antennas that are tuned properly to those frequencies and operate optimally on those frequencies. The other critical point with your UHF CB antenna is the mounting location, and we'll talk more about the mounting location as we get into further slides. So our ideal antenna is an antenna that radiates equally in all directions. Doesn't matter whether our mates are behind us or in front of us or off to one side, our antenna's got to perform in all those directions. The challenge with that is it may not be practical to mount the antenna in the centre of the roof where it gets a clear view all the way around it. So depending on where you put the antenna on the vehicle, the performance in different directions can be affected. Ideally, we'd love to have the antenna mounted in the centre of the roof, but we all recognise that's not practical, so what do? We have to compromise somewhere. So we all know, pretty obvious statement, most UHF CB antennas, particularly in the four-wheel driving market, are mounted on the bull bar, or at the very least, on the front guard of the vehicle. What we say is mount the antenna as high as possible on that front guard of the vehicle. The reason we suggest that is if you get it up reasonably high, the antenna can see through the windows of the vehicle rather than through the metalwork of the vehicle, and that will help your coverage behind the vehicle. We'll go on with a little bit more about mounting a little bit later, but what I want to talk about now is gain. I guess most of you will have, if you have a UHF CB, will have heard of antenna gain. So we want to explain to you what gain actually is. And again, this comes down to the smoke and mirrors. So gain is measured in dB, or decibels. And here's an example of a relatively low gain antenna, 3 dB. What that antenna is actually doing for us is it's radiating some energy out on the horizontal plane, trying to get to our mates on the left and the right of the screen there, that might be 5 or 10 k's up the road. But it's also wasting a lot of energy. A lot of that energy coming out of that low gain antenna is going straight up out into space and straight down into the ground. So our problem with this scenario is that our mates are out of range of us because we're not concentrating that energy out on the horizontal plane. So how do we fix that? We fix it by increasing the gain of the antenna. So here's an example for you, 6 dB of antenna gain. If we go to a 6 dB antenna, which would typically be an antenna of this sort of height, about 900 mil, all these antennas here tend to be about 6 dB. What we've done now is we've taken some of that energy that was otherwise going up and down where we don't want it, and we're focusing it out on the horizontal plane. So it actually enhances our range out on the flat planes to get us better coverage. And as you can see there, the example we're trying to put there is that we've just managed to get our mate on the right there, we've just got coverage there, but on the left, we're still a bit marginal. How do we fix that? More gain. Let's get a bigger number. So we go to the high gain antenna, a 9 dB antenna, and we've got to the point where we've scraped up so much wasted energy now and focused that out on the horizontal plane that we can now get coverage to both our mates off in the distance. But it doesn't quite end there because hilly terrain. When we get into hilly terrain, our 9 dB antenna that was U-Butte gangbusters in the previous screen now has some really big problems. 9 dB, down the hill we're overshooting the mark. Our mates down in the valley, we're focusing that energy straight over the top of you. Going the other way, we're focusing energy straight into the side of the mountain, and we're still not getting our mate at the top of the hill. So gain is not really your friend when you get into the high country. We can fix that. 6 dB antenna. We reduce the gain. We fatten out that vertical beam width of the antenna. We reduce our maximum range a little bit, but we actually start getting coverage back down into the valley. You see, we've still got a little bit of a problem, and that is that we can get coverage to our mate down in the valley, but we're still a little bit marginal to the guy at the top of the hill. Maybe we're there, maybe the signal's a bit scratchy, we're not quite there. How do we fix that? As you can see, we go down to the 3 dB antenna, the low gain antenna. We've now reduced our total maximum range quite significantly, but we've now filled in those close-in gaps to give us the coverage in the hilly terrain. So all we're saying there is just keep in mind that gain can be your friend, but equally it can be your enemy, and you might want to think about the sorts of terrains you're operating in before you make a selection on antenna, or you may want to think about having 2 different types of antennas to give you those 2 separate gain figures, so you've got the best of both worlds. So we've just a little summary up there on the screen now. Low gain antennas around 2 to 4 dB. They lack range, but they're great in hilly terrain. Middle of the road, medium gain antennas, 5 to 7 dB, about this sort of size. And interestingly, I'm sure you guys will have observed that most 4-wheel drivers you see run an antenna around about that sort of height, around about 900mm. They're in that sweet spot of compromise in gain. Reasonably good range in the flat, and reasonably good range in hilly terrain. And that's why we have antennas about that sort of size. Again, we can go to a higher gain antenna, an 8 dB antenna. We don't see a lot of that, and the reason for that is to get extra gain, we must have a bigger antenna. When you get to 8 or 9 dB, you're talking about an antenna that's about 1.8 to 2 metres tall, and really getting to the point where in a lot of cases, they're quite impractical. So ultimately, you're looking at a high gain antenna, very high gain antenna, being very poor in hilly terrain, great out on the flat, but is it really practical? Some people will say yes, some will say no. I just want to talk a little bit about some specific RFI product now. This is our flagship product, and in fact I'd like to do a little bit of show and tell with this, and if people would like to just pass this around. Our CDQ 5000 antenna is based on our painted and printed circuit board design, and we're sharing our printed circuit board design with you in that transparent sample right now. The printed circuit board design has the benefits that there are no mechanical parts inside the antenna. So basically, as that's barrelling down some old dirt track somewhere and shaking itself to bits, there's nothing to break inside that antenna. And that makes it an extremely robust antenna. The other thing we really like about it in our factory here in Bayswater, where we manufacture the product, is that it's very reproducible. So it minimises any opportunity for human error in the manufacturing process, which really helps us a lot in our quality control in the factory. That is actually an RFI patent, that printed circuit board. That's actually good old Aussie ingenuity, and that's a patented design. In addition, this particular product features that you can actually remove the whip from the spring, and it does give you the opportunity to either replace the whip if you do happen to damage it, clobber it on a low-flying branch or something. And the other benefit is that you can optionally put a low-gain antenna on, just a little short 3 or 4 dB antenna, if you're in the high country, so it gives you that flexibility. And equally, it's kind of nice to be able to have a little spare flexible whip in the glove box, just in case you do clobber it while you're out on a trip. So just on to the next product, our CD5000, which is very similar to the antenna we're passing around now. It actually shares the exact same printed circuit board, the same patented technology, and performs exactly the same as the unit on the previous slide. The only difference is you can't remove the whip, and you can't replace the whip for a smaller, lower gain unit. But it is at a much lower price point, which I guess just gives you another opportunity that if the replaceable unit's a little bit beyond your price tag, you can still get the same performance in the CD5000 product. I should hasten to add, we do make cellular telephone equivalents of these antennas. They look exactly the same, but they have the cellular element inside them. So if you do need a cellular antenna, you can have a cellular antenna and a CB antenna that look exactly the same on either side of your bull bar. Just something worth considering. The other product I'd like to talk about is our elevated feed. We've got some of those on display here now. Something that makes the RFI product rather unique is the types of whips that we actually put on the top of these elevations. And in fact, I'll just point to the whip on the right there. It's very hard to see the detail in this photo, but that's actually dual layer injection moulded synthetic rubber covering the stainless steel whip there. Our engineers have put, I just can't imagine how many hours into to testing and trialling different materials. They've come up with this design now where they reinforce down at the very bottom part of the whip assembly there, and then injection moulded rubber coated over it to stop any potential for fatigue failure down at the bottom of that whip. And that is actually a well-known cause of failure in that antenna design for other manufacturers. We've actually solved that by virtue of this injection moulded rubber arrangement. So that's something a little bit unique about RFI. We can't break them in the test jigs in our factory, and we haven't had any customers break them yet since they've been on the market. In addition to that, we do a fiberglass version, which is popular with some customers. Again, what we do is we reinforce around this bottom area to ensure that we've got a whip with the integrity that it will put up with all of this that goes on when you're barrelling down some bush track. In addition to that, we do use a thicker fiberglass blank for the fiberglass version than some manufacturers, just to make sure that we've got that extra rigidity in there. So really, what we're talking about here is an antenna that is tough, it's fit for purpose, and it ain't going to break. Also, a little bit hard to see, but we also have a low gain whip available for that product as well, which again gives you that opportunity to either have a spare in the glove box in case you do break something because you clobbered it, or low gain for when you get into that hilly country and you need a lower gain antenna to get the coverage you want. A couple of quick and honourable mentions. Our CD63 product, very popular with some. I find some of the people I talk to find that one of these thick type antennas in front of the vision on the bull bar is a little obtrusive. Some people really like that skinny little thin wire whip. Very robust, great performance, 6 dB of gain, and very reasonably priced. So just something to consider if you find that something big like this in your field of view is a bit of a distraction. We do have some little antennas with our rubberised injection moulded covering over the top of them. Great product if you want to put something up on top of the roof racks. Gives you good clearance because it's only about that high. It's reasonably low gain, but it does perform quite well because it's up high and it's actually getting clear line of sight around the vehicle, as long as you haven't got the jerry cans right next to it, which won't help. Brackets, look, huge range of brackets. I won't go into too much detail there. There's probably better things we can talk about tonight. I did want to talk about a new product. This is almost as new as our new Prime Minister. This new product allows you to mount your antenna on the bull bar in the normal bull bar bracket that you would have flat on the top of the bull bar, but it allows you to knock the antenna down. It's a little spring-loaded arrangement. You pull the pin, you can knock the antenna down 30 degrees, 60 degrees, and even 90 degrees. So if you just want a quick knockdown, or if you even want to knock it down 30 degrees, just to get you a little bit of clearance somewhere, but you still want your UHF CB working so you can talk to your mates, that's a great product. Given the practicalities of where we're mounting the antennas, where should we mount them? Front guard's a good place because we're getting it up reasonably high without getting it to the point where it's going to get clobbered. Bull bar, perfect choice for all my new friends here. And the roof rack is another great place, but I just hasten to add, you probably wouldn't go and put an antenna that size on the roof rack. Do's and don'ts. Antennas side by side on the bull bar. I see this quite regularly, and I just can't emphasise enough that this is doing you no favours in terms of your performance. There's a few things going on there. The first thing is one antenna will detune the other antenna, so neither antenna will perform very well anymore. They're so close together that the two systems are likely to interfere with each other. So your cellular phone's likely to interfere with your UHF CB and vice versa. And the other thing is RF radiation doesn't go through metal very well. And of course, what's an antenna made out of? Metal. So when you're trying to get coverage in that direction and that direction, it's not going to work very well because it's all going to get absorbed by the antenna you've got next to it. So the optimal mounting location for this particular customer would be just to have the two antennas on either side of the bull bar. Another one we see fairly commonly, and really again is doing you no favours in terms of your coverage, is having the antenna down low on the vehicle like that. There's two things going on in this picture. The first thing is, you can see the top rung of the bull bar there is running right parallel perpendicular to the antenna whip itself. What that's doing, that metal in proximity to the antenna is completely detuning the antenna and causing it to perform very badly. But not only that, we're now trying to, if we're trying to talk to our mates behind the vehicle, we're now trying to radiate all our RF energy straight into the metalwork of the vehicle, through the panel work, through the engine block, and I can tell you that metal is not very friendly to RF radio signals. It will basically block it completely. So this guy's probably complaining about his radio, but it's actually his antenna mounting location. It's certainly not his antenna, because I can see it's a quality RFI product. The place to mount that is obviously on the top rung of the bull bar. Great thing about doing that is you've got most of the antenna radiating element level with the glasswork in the vehicle, and glass is actually reasonably opaque to radio communication signals, so it'll actually penetrate through the glass much, much better than it will through the engine block. So another do not do. Nearly at the end, guys, I did want to make mention of our friends at G&C Communications. G&C Communications have been a dealer of RFIs for many, many years, and I'd like to thank Amy and Graham for coming along tonight to support us for this presentation. Lucky last one. Is there any questions? Has anyone saved anything up? Yes?
You mentioned just before about the optimum positioning of, let's say, dual aerials on the bull bar, while you might have mounting points on either side. What's really the minimum you can get away with in having them mounted on the one side?
Really hard to give you a minimum. I would just encourage you to get them as far apart as you possibly can, and that is practical for you. 0.5 metre, Graham says, and he knows more than I do.
I have a question for you too. You haven't answered my question with notice. The effect on 80 channel and 40 channel radios?
No worries, thanks Stuart. Okay, so 40 channel and 80 channel radios. Basically, the Australian Communications and Media Authority expanded UHF CB to 80 channels in the recent years. In doing so, what they did was they interleaved extra channels in between each of the existing channels. Now, what that does is it gives you some level of compatibility from one transceiver to the other. Every second channel now works. But there's also another change in the modulation technique in the radios, and ultimately what that does is it means if you're talking to a guy with an old 40 channel radio, he's going to sound really loud to you and you're going to sound really quiet to him. So there's some level of compatibility there, but it's not perfect. So I guess all I would say is if you buy a new 80 channel radio, you're then perfectly compatible with the modulation technique, and you'll get a better result because the radios are 100% compatible with each other.
You were saying that a 3 dB is good for certain areas and a 6 dB is good for other areas. So if you put a 3 dB one side of your bull bar, a 6 dB the other side of your bull bar, how do you switch them? Do you put both leads into one plug, or do you have a double pole, double toe switch and you switch one to the other? Which is the preferred method?
Thanks for the question. When we talk about swapping antennas, we generally don't suggest that we have one antenna on one side of the bull bar and one on the other. What we're generally talking about is actually unscrewing the whip. I've got a little assistant who's going to help me. Unscrewing the whip, high gain whip, big one here, and then replacing it on the bull bar with a low gain whip. I think I might have lost my low gain whip, but I did have a little whip that's only about 6 inches long that will screw on the top of that, and that actually reduces the gain of that antenna down to about 4 dB. So we go from 6.5 dB down to about 4 dB. I'm not sure, Graham, can we still get coaxial switches if we wanted to do that? So look, the guys at G&C could actually do that for you if you wanted to do it. Yeah, the question was whether putting a switch in actually loses performance. I think Graham will agree with me if I say if it's done right and done properly with the right equipment, you won't be able to tell the switch has been put in there. There'll be virtually no loss in what you're doing.
Is there any difference in interference between the alloy bar and the steel bar?
No difference whatsoever.
I'm sure we're all aware of how, or the fact that there's repeaters out there, but I'm sure that most of these members wouldn't really know how to make a call through a repeater. Would you be able to explain that for us?
First thing I would encourage is if you go online on the internet and do a little bit of Googling for UHF CB repeater list, you'll find probably several websites that will give you a list of where the repeaters are located and what channels they operate on. Now, back in my day of playing with UHF CB, which was the old 40 channel system, the repeaters were on channels 1 through to 8, Graham. They're still on channels 1 through to 8. So you'll have what we call a duplex button on your radio, or a repeater button. So you press the repeater button in, You select the channel for the repeater in the area you're in, and that's why you need your list. Once you turn the repeater button on and you select the channel, either 1, 2, 3, up to 8, you operate the radio as normal. You key the microphone, your signal goes out on one of the higher channels up to the UHF CB repeater, and the repeater then retransmits it back out on that channel that you're on, channel 1 or 2 or 8 or whatever. As long as the person you're trying to talk to does the same thing, selects the same channel for the repeater in your area, let's say it's channel 1, puts his repeater button or his duplex button on, you'll be able to talk to each other through the repeater. How are we going for time, Stu?
Yeah, I think we're going pretty well. You had another task you can do?
I do have another task.
Surprise?
I have it on good authority that my friend Stu has popped a sticker underneath somebody's chair tonight. What does the sticker look like, Stu?
It's a visitor badge with the winner written on it. So somebody has a sticker under your chair.
That winner will be the proud recipient of RFI's flagship product, its CDQ 5000 dual bit kit.
I think the person who has the sticker has not yet moved from their seat to check. That would be the one.
We have a winner! Well, thanks everyone for your time tonight. That's it for us. I'd just like to encourage you, we'll be hanging around for a cup of tea. Come and talk to us. We'd love to answer any further questions you have. And certainly we've got a lot of product here on special, so if anyone does need to make a purchase, we can help you with that as well. Thanks a lot, guys. Good night. Thank you very much.